Section 3.1 is about us writing and analyzing conjectures by using inductive reasoning. Inductive reasoning is the process of reaching a conclusion based on a pattern of examples. When you assume that an observed pattern will continue, you are applying inductive reasoning. You can use inductive reasoning to make an educated guess based on known information and specific examples. This educated guess is also known as a conjecture. Example 1, we're going to write a conjecture that describes the pattern in the sequence. Then we're going to use our conjecture to find the next term in the sequence. Remember, conjecture is just an educated guess based off a pattern of events. So my appointment times that we see are at 8:30 a.m., 9:15, 10, and 10:45. So I'm looking for a pattern. As I look at these, I see the pattern is there's an appointment every 45 minutes. So that is my conjecture. With that being said, I can use that conjecture to find the next term. So if I add 45 minutes to 10:45, that puts me at 11:30 a.m. Pause the video and try the check question. So in the check question, you are supposed to write a conjecture. So as I look at my numbers and see the pattern, I see that we are multiplying by 2. That is my conjecture. I can use that to find the next term. So the next term would be 8. Example number 2, we're going to use algebraic conjectures. Make conjecture about the sum of the squares of 2 consecutive natural numbers. List or draw some examples that support your conjecture. So first off, a lot of vocab. Sum means that we are adding. Square means that you're doing it to an exponent of 2. Consecutive means they are right next to each other in the number line. So like 1, 2 are consecutive. And natural numbers, meaning numbers that are whole starting at 1. So 1, 2, 3, 4, etc. are natural numbers. So we're going to list some examples to get started. So here they have 1 and 2. So 1 squared plus 2 squared. So I'm adding the squares of 2 consecutive. When I add them, I get 5. Then I'm going to do the next 2. So 2 and 3 would be the next 2. When I square them and add them, I get 13. Then I just randomly pick some variants, so 6 and 7, 10 and 11, and this is what I got. Based off of these sum numbers, I'm looking to see what conclusion can I make. I notice that all of these sums end up being odd, so my conjecture would be that the sum is odd. Pause the video and try the check question right below. Make a conjecture about the sum of 2 odd numbers. So sum again means you're adding. Odd would be numbers 1, 3, 5, and 7. So I picked some examples to get started. So I picked 1 and 3, added it and got 4, 3 and 5, which is 8, 5 and 7, which is 12. So I just find some examples and then I'm going to look at their answers and see what the pattern is. Well, one thing I notice is that all of those are ending up being even. So therefore, my sum will always be even. Example 3. Now what can you do with geometric conjectures, so pictures? Make a conjecture about the relationship between the segments joining opposite vertices of isosceles trapezoids. First, knowing what an isosceles trapezoid is. So a trapezoid has 4 sides where you have one set of parallel sides. Isosceles means that these two are going to be equal. So we drew various sizes of them, and then your diagonals are going from one edge to the opposite side. So it kind of looks like no matter what, I'm seeing a pattern that my segments end up being congruent for that trapezoid. So these look like they're the same length. These look like they're the same length. So the book suggests that you could even get a ruler to confirm this, but it does work out. So the segments from opposite sides of those trapezoids are congruent. Pause the video and try the check question. In the check question, it's asking about the relationship between AD and AB if C is the midpoint of AB and D is the midpoint of AC. So what you always want to do is draw a picture. So I started with drawing the line AB, and I put C as the midpoint.
Students waiting for the buses. The buses are ready to go, so you need to be boarding soon. Thank you.
D is the midpoint of AC, so I put D as the midpoint here. So if these two distances are equal and these two distances are equal, I would also know that these two chunks would fit over here. So how I wrote it was that my conjecture is I can do 4 times the length of AD to equal the full length of AB. You also could say that AD is 1/4 of AB. So 2 different ways to write the same thing. Example number 4 is where you can make conjectures based off of tables or data. So this table shows the average price of gasoline in the United States for the years 2010 through 2018. Make conjecture about the price of gas in 2019. Explain how this conjecture is supported by the data given. So I looked for patterns. So I noticed that from 2010 through 2012, it was increasing. It started to decrease all the way through 2016, and then it started to increase. Since it was increasing or decreasing for more than 2 years, I would suggest that in 2019, the gas price would continue to increase based off of these patterns. So my conjecture would be that it was increasing. My explanation would be that they have shown that it would be more than 2 years that it would continue with that pattern. Pause the video and try the check question. So in this question, you are supposed to be finding how long does it take to cause hearing damage at 106 decibels. If you look at your pattern, it looks like you are dividing by 2. So and this is increasing by 3. So if I increase by 3 and I divide by 2, the next one would be at 1/8. And if I increase 3 again, I'd be at 106, and I divide 1/8 by 2, I'd be at 1/16. So I would have 1/16 of an hour. It did ask for me to write it as a decimal, so I just found 1/16 of an hour. So that means I did 1/16 times 60, and that's where I got 3.75 minutes. So these are the same answer. You can write it either way, and it would be the same. Okay, so the other part of this lesson is us finding counterexamples. So to show that a conjecture is true for all cases, you must prove it. It only takes one example that contradicts the conjecture. However, to show that a conjecture is not always true. This example is called a counterexample. It can be a number, a drawing, or a sentence. Find a counterexample to show that each conjecture is false. So if n is any real number, then the opposite of n is a negative number. So my counterexample is, what if you had n be equal to -3? The opposite of -3 is +3. That would show this statement is false. Letter B. If these two angles are congruent, then these two angles have to be vertical. I can think of an example where two angles are congruent, but they are not vertical angles. So ABC is equal to 90, DBE would be equal to 90. So they could be any kind of congruency and not be vertical. They could be perpendicular and a linear pair. Pause the video and try the check question. So if n is a real number, then 1/n is less than n. Select all that applies. So the best way to do these kind is just plug them in. So if I put in -3, I would have 1/3 is less than -3. Just be careful with these, because when you are dealing with negatives, the smaller the number, the bigger it is with negatives. So -1/3 is bigger than -3. Then I would put in 1/4. So 1 divided by 1/4 is actually 4. And then I'm checking if that's less than 1/4. That is false. So that's why this one is a counterexample. Putting in 1. 1/1 is less than 1. That's not true. It is equal to, but is not less than. So that is a counterexample. 1 over 5 is less than 5. That's true. 1 over 100 is less than 100. That is true. So just the first three would be counterexamples. Letter B. If a line intersects a segment at its midpoint, then the line is perpendicular to the segment. Draw a diagram to represent the counterexample. So I drew a line that was a midpoint, and then I drew a line that was intersecting, but it was not perpendicular. So as long as you don't have it vertical, you just have any kind of slanted line, that would work. All right, section 3.1 is about making conjectures, finding patterns, and then also using counterexamples.